If you've ever built a React app, you definitely know the feeling. You start out small, everything is simple, everything is working great, and then it starts to grow. All of a sudden, you're trying to juggle data all over the place, you're worried about performance, and you're staring at a dozen different libraries. Well, today, we're going to walk through that exact journey, from a single, simple component to a full-blown, complex application, and we'll explore the tools you need at every single step.
So this is the million-dollar question, isn't it? The React world is just packed with these powerful tools, but figuring out the right one for the job, and just as importantly, when to use it, can be a real challenge. Our whole goal here is to break down that decision-making process so you know exactly which tool to reach for and why.
Every single application has to start somewhere, usually with a simple idea and maybe just a handful of components. At this early stage, our needs for managing state are just as simple.
And it all begins with useState. This is your bread and butter. If you've got a counter or form input or maybe a simple toggle that only affects the component it's actually in, this is it. It's the perfect, most direct solution you can ask for. There's absolutely no need to over-engineer things right from the start. But it never stays that simple for long, does it? Soon enough, your app grows. Now you have a user's theme settings or maybe their login status, and you need to get that information into a bunch of different places. And that's when you hit your first real hurdle. And this leads to something that developers famously call prop drilling. It's so frustrating. You end up passing props down through 5, 6, maybe even 10 layers of components that don't even care about the data. They're just passing it along. Your code gets messy, hard to read, and a total nightmare to refactor. It is a classic growing pain. Now, to solve this prop drilling problem, a lot of us immediately reach for React's Context API. But hold on. Here's a really crucial insight from Mark Erickson, one of the Redux maintainers. He says that thinking of context as a state management tool is fundamentally a misunderstanding. So, if that's not its main job, what is it actually for? The answer is dependency injection. Now, that sounds complicated, but the idea is simple. Context's main job is to broadcast a value, any value, down to a tree of components below it. Think of it like a loudspeaker. It just makes that information available to any component in that part of the tree that wants to listen in without you having to manually pass it down everywhere. So context is fantastic for things that don't change very often, right? Like a theme or user authentication data. But what happens when you have really complex application state that's changing all the time? Well, this is where relying on context can start to cause some serious growing pains. And this right here, this is the performance trap. Let's say your context holds a big object with 10 different properties. If you update just one tiny piece of that object, every single component that consumes that context is going to re-render, even the ones that don't care about the piece that changed. This can absolutely slow your application to a crawl. And this table just illustrates that core difference perfectly. With context, your state lives inside a React component, and updates happen through React's normal re-rendering system. Redux, on the other hand, is totally different. It puts your state in an external store, completely outside of React. Components then subscribe to just the pieces of state they care about, which is way, way more efficient for complex stuff. And on top of that, Redux gives you powerful extras like middleware. Okay, so far we've only been talking about state that lives inside our app. But let's be real, most applications need to interact with the outside world. Fetching data from an API, setting timers, all that good stuff. In React, these are called side effects. To handle these side effects properly, we have to understand the component lifecycle. You can think of it like a little story. A component is born or mounted. It lives its life and changes or updates, and eventually it's removed from the screen or unmounted. The useEffect hook is our key to tapping into these really powerful moments. But useEffect comes with its own classic trap. Okay, picture this. Your component mounts and kicks off a data fetch. But the user's fast, and they click a link to navigate away before that fetch is finished. So the component unmounts, but the network request is still out there. When it finally finishes, it tries to update state on a component that doesn't exist anymore. That can lead to memory leaks and weird errors in your console. Thankfully, the solution here is really elegant. The useEffect hook lets you return a cleanup function. This special function runs right before the component unmounts. So inside it, you can use a tool like an abort controller to cancel that network request, making sure you never try to update a component that isn't there. It's so important. Always clean up your side effects. All right, so you've got your state under control, you're handling side effects, but now your app just feels a little sluggish. As your app gets more complex and data-rich, you're going to hit the next big wall: performance. Unnecessary re-renders are the silent killer of a good user experience.
Here's a key thing to remember. Just because a parent component re-renders, it doesn't automatically mean all of its children need to as well. I mean, think about it. If their props haven't changed at all, then re-rendering them is just completely wasted work.
And this is exactly where React.memo comes into play. Think of it like a protective shield you wrap around your component. You're basically telling React, hey, before you re-render this thing, just do a quick check. If the props it's getting are the exact same as last time, don't bother. Just reuse the last result. It is your first and easiest line of defense against those wasted renders. Next up is useMemo. Now, while memo is for entire components, useMemo is for values inside your components. Imagine you're doing some really complex, time-consuming calculation on every single render. useMemo lets you cache the results of that calculation. It'll only rerun the heavy lifting if one of its specific dependencies changes, saving you a ton of processing time.
And that brings us to the third one, useCallback. This one's a little more subtle, but it's absolutely crucial when you're passing functions as props down to those components you just wrapped in React.memo. See, without it, you're creating a brand new function on every render. To JavaScript, that new function is different from the old one, and that difference breaks the memoization of your child component. useCallback solves this by giving you the same stable function back every time, preserving that performance boost.
Okay, we have covered a lot of ground. And you might be sitting there thinking, wow, this sounds a little complicated. And you know what? You'd be right. The good news is the React community thought so too, which brings us to the modern era of state management. For the longest time, using Redux meant writing a ton of boilerplate code. I mean, you'd have your action types in one file, your action creators in another, and your reducers in a third. It was incredibly powerful for sure, but it was also really verbose and kind of a pain to set up. And then Redux Toolkit came along, and just look at this comparison. It's night and day. On the left, you've got the old way, spread out across multiple files, and on the right, the modern way, with a single function, create slice. It automatically generates your action types and creators right from your reducer functions, all in one clean, concise block. It's the same powerful Redux you know, but with all that tedious boilerplate just stripped away. It's a game changer.
So let's bring it all home. The journey of a React developer is all about choosing the right tool for the right scale of the problem. You start simple with useState. You use context for broadcasting stable data, not for rapidly changing state. You bring in the power of Redux when your state gets truly complex and global. And you always stay mindful of performance by cleaning up your effects and memoizing strategically.
We've basically laid out the entire map and the tools for your journey. The path from a simple component to a complex, performant application should be a whole lot clearer now. The only real question left is, what amazing thing are you going to build next? Thanks for tuning in.